Hi. If someone asks you how come an object will fall to the ground when you release it in the air, then you probably say, oh, because of gravity. We call this kind of motion as free falling. Free falling has always been one of the biggest problems that the scientists want to understand in the past. And of course, nowadays it has been much well understood already. Imagine if you are those people who first think about this, how would you try to explain the reason of free falling, and also how would you explain why maybe for different objects they may fall differently. So for now, I would like you to try solving the first 3 questions on this page. Pause the video, try yourself, and I'll explain the answers to you.
A few moments later.
Let's check the answer. For question number 1, it asks you between a blowing ball and a feather, which one would land first? And I'm pretty sure that your answer will be, of course, the ball would land first. You can imagine, without doing the experiment, you can imagine the feather will kind of go like this, and then it takes quite long time to reach the ground, while the ball would just simply go straight to the ground. So the ball would land first. For question number 2, I asked you to get 2 pieces of A4 papers, which means they are identical, and I want you to crumble one of them as a ball like the picture, and the other one remain the same as a plain sheet. And I want you to drop them at the same height. And so which one you should find landing first? And the answer, you should find out the one that got crumble one should land first. Alright, if you haven't done the experiment yet, please do it now. In case you say, oh, I don't have A4 paper at home, what you can use as a substitute could be toilet paper. Okay, I'm pretty sure that you have it at home. So what you can do is you crumble one of them as a ball, as hard as you can maybe. And so once again, the main purpose of this is, since they are of the same size originally, like same one piece of toilet paper, then I'm sure that they are the same mass. Okay, so right now, what you could do is like what I'm doing right now. I'm going to drop it down in 3, 2, 1.
3, 2, 1.
Yes, my pose was very funny and ugly, right? The reason why I'm trying hard is because I really want you to experiment it yourself. So please make sure you try it. This is a way to learn physics. So now, if you try to think about the reason why some object will fall faster than the others, then from the first example, you may see, oh, the ball will go faster than the feather, maybe because the ball is heavier. But then when you look into the second example, then you find this is wrong, because when you have the same mass of the object, but one of them got crumbled, it's still the same mass, right? You just change the shape. But then the crumbled one will somehow go faster than the flat paper. So maybe because of this, Galileo in 1589 performed an experiment, and that is a very famous experiment called the Tower of Pisa. And yes, he did it in the Tower of Pisa. That he literally bring 2 lead balls to the Tower of Pisa and drop there. Alright, of course, it's a very dangerous experiment nowadays if you want to do it, because you may just drop the ball on someone else and crush their body. But then back that time, because of science, he wanted to do it. The special thing about this is one of the ball is actually 10 times bigger than the other one, and therefore 10 times heavier. Both of them are lead ball, and when he drop it, he find out that both ball actually reach the ground at the same time. So they literally having the 2 ball, one is bigger, one is like tinier, and they reach the ground at the same time. So what can you deduce from his experiment as well as our experiment in the first and second scenario then. For Galileo's experiment, we can actually deduce that the mass does not actually affect the time of free falling because he used obviously two balls, one will be 10 times greater of mass than the other one. Or you can say that the time of flight of free falling is independent of the mass. However, from scenario 1 and 2, so how come we would observe a difference when you drop a ball and feather or maybe two pieces of paper, one is crumpled, one is not crumpled, then you may need to think of another reason. So other than the mass, something you can consider between example 1 and 2 is that it's something to do with the shape itself. Okay, and the shape actually will affect how much something called the air resistance, which we'll talk more in maybe 1 or 2 videos later. So this was actually the reason why the feather and also the flat paper will fall kind of slower than the other two items. So now I would like you to think very creatively. Can you suggest a situation where the ball and the feather can land at the same time? So literally this ball and this feather, how can they land literally at the same time? Of course, they still are released at the same height. You can't say, oh, let's put the feather lower and the ball high. You can't do that. They are still released at the same height and you just release them. That means the initial speed is 0. You can't just say, oh, let me kind of push or flow the feather down or flow the ball upward. No, you can't do that, right? It's still released. That means no speed at the beginning and also the same height. How can you get them to land at the same time? Pause the video and think about it.
2,000 years later.
There are actually 2 solutions in total, and in fact the 2 videos down below are the solutions. Let me explain to you quickly. The first one is actually to vacuum out all the air in the room. Okay, the reason is that because earlier we explained that the reason why some object will fall slower or taking longer time than the others is because of their shape and somehow produce more air resistance or experience more air resistance, to be more precise. And so if we try to minimize the air resistance, we can actually minimize it by simply taking all the air away. So in that case, if you don't have any air, you cannot have any air resistance, obviously. The second solution is somewhat fundamentally the same. However, instead of doing it in a room, we can actually do it in the space because there's no air or very little amounts of air in the space. The first experiment that we are talking about is actually located in NASA. So it's not something that you can do it easily at home or in the school lab because you literally had to vacuum out all the air in the room and it's not easy at all. First of all, you need a very strong engine to do that. Second, you will need a very hard wall to ensure that the wall will not crumble, right? Because if you have a very little pressure inside the room, then the outside air will try to push the wall, and so if the wall is too thin, then you're basically destroying the wall, basically. And one thing that of course we will need to pay attention is there shouldn't be any people inside. Otherwise, of course, you'll be dead. Well, actually, it's not because of you are out of breath, like you are out of oxygen. It's before you are out of oxygen, something that will happen if you're inside that vacuum room. Something horrible will happen, and that is your body will literally go explode. The reason is that imagine outside of your body, the air got pumping out, so it become no air almost. So the air pressure will be very low. However, inside your body, you still have air somewhere in your lungs and also in your body tissue as well. So in that case, then the air inside your body won't to come out. And so what happened is then you become like a balloon that you got inflated, it become larger and larger, not because you get more air, it's just because your air inside your body want to escape from your body, so you literally got expand, all right, and eventually your body cannot hold that expansion and you got explode. So right now in the video they are going to vacuum out all the air now, and let me just go straight. And by the way, just now they try to simply drop it and you see the ball will go down first. All right, this is a control experiment just for you to see normally under the circumstances with the air, the ball will reach the ground first, obviously. Okay, and so now they are going to vacuum it out. It takes, of course, quite a bit of time. And so, okay, now it is the moment of truth. Let's watch it together. You can see the feather and the ball literally are parallel to each other, right? They drop literally at the same time, and that is actually amazing because that means it proves our theories correct. You can see how happy these people are, right? Of course, these people are all very passionate about science, astronomy, and physics, of course. And probably this is the first time people actually have done this experiment on Earth, because it was not easy without the technology back that time. Imagine Galileo cannot do this, of course, without the machineries. So amazing, of course. So if you want to check out the video again, I'll put a link in the description below, and please feel free to watch it over again. It's just amazing. I would love to watch it at least 3-4 times. Here comes the second video about doing the same experiment on space. And well, from the quality of the video you can tell this is a very old video. In fact, the experiment that we talked about earlier just now about the vacuum chamber was done probably in 2014, which is actually not long ago. For this one, you can see the video got uploaded in 2010, but actually it is not done in 2010. It's way earlier than that, right? So don't get fooled by just the day that the video got uploaded. If you try to search it, you'll find out, well, this is done when people try to land the moon with Apollo 15, and that was 1971. I wasn't even there during that time. Anyway, so let's watch. So let me show you just like the most important part. Again, the video is not in a very good quality back that time, but imagine 1971. I guess that would be the best already. So instead of a ball, what the astronaut had was a hammer on the left of the screen, or his right hand, and the feather is on the other hand, obviously, on the right hand side of the screen. So wait for it. Let me full screen. Hopefully, yes, there it is, right? They land at the same time. Let's watch it again because it's so satisfying. All right, you can see they land at the same time. So let's just watch it again, all right? Again, it's very satisfying. Let's just watch it with maybe a slower speed, 0.5. Okay. And so yes, very nice, very satisfying. Alright, so in this video you learn about the basic idea of free falling, and you can also identify whether the mass, the shape, the air resistance may affect the time of free falling or not. And hopefully starting from now on, you pay more attention to our physical world. Use your eye to see, use your ear to hear, and use your brain to think, and try to seek a physical explanation to all the patterns that you see in our physical world. In the next video, we'll talk more about free falling. So I would like you to try to do this question by yourself first, and I'll explain the answers to you. I hope you enjoy learning with me. If you do so, please like the video and subscribe to my channel. I'll see you again in the next video. Bye.